f of xy equals the square root of y minus 3x. Can anyone get us started? We are only asked to find a domain of function f. What should we write? What do you think? Anyone? What should we write?
0 positive infinity.
That y minus 3x has to be strictly greater than 0 because the square root from a negative number is not real. I see the square root, the quantity under the square root always has to be greater than or equal to 0. So in other words, y has to be greater than or equal to 3x. So then the domain of function f consists of, or equal symbol, y greater than or equal to 3x. The ordered pairs x comma y. So that the domain of function f is consists of ordered pair such as or having the property that y has to be greater than or equal to 3x. Now, for example, if we look at one more, let's say 9 on the same page. Any questions on this? Any questions on why we state that? Any questions? Okay, so for example on 9, I see f of xy equals x squared plus 4x plus y squared. There are no restrictions. So x and y can be anything. So the domain of f consists of all the pairs with x comma y anywhere between negative infinity and infinity, not equal to. Oops. That's it. There is nothing. I don't have anything to write. Okay, let's say also one more. I see h of x comma y equals x e to the square root of y. Do we have to write any restriction for x? Do we have to write any restriction for x? Anyone?
No.
No. Very good. Do we have to write any restriction for y? That's it, or equal to. It can also be 0 because the power can be 0. Very good. Any x, I don't have to mention anything. Y greater than or equal to 0. That's it. That's all I need to do. If we don't mention anything about x, it means x can be anything. Okay. That being said, and we can go back to other problems if you find anything in my lab math. Okay. So finally 6.2. Derivatives. Why we want derivatives? Because we want to find max min, right? In the next section, and that's the end of the course. Derivatives of functions of several or multiple, same thing, variables. So if you give me a function like, let's say, x to the third plus 2x, and you ask me to find f prime, what will I say? Anyone?
3x squared plus 2.
That's it. But if I'm given a function with 2 or more variables, like for example, x squared y plus 3 y squared plus 4 x cubed y squared, that's a totally different story. If you ask me to find the derivative of this function, you have to be specific. So if you want me to find, so this is first question, find the derivative of f of x comma y, this one, when y is fixed. Then I will differentiate, first of all, with respect to x, but y is fixed. And that notation is not going to be dy, do not write it, I'm going to cross it out. It's not going to be dy over dx, it's not going to be df over dx. All of these mean this, right? The notation of dy over dx, df over of dx, and f prime of x are specific for functions of one variable. If you want me, or when y is fixed or x is fixed, doesn't matter. We will be very specific. The notation is totally different. It's this. df over dx. What does this mean? That the function has more than one variable, not just x. But I will differentiate with respect to x, keeping y fixed, or the rest of the variables fixed. How will I differentiate with respect to y? df over dy. These are called partial derivatives. This is the first derivative. This is the first derivative. This is the first derivative for functions of one variable. But if a function has more than one variable, more than one variable, x, y, z, etc., etc., I can only determine partial derivatives. I can determine also the second derivative, the second partial derivative with respect to x. I can also determine the second partial derivative with respect to y. So partial derivatives, first partial derivative with respect to x, partial derivative with respect to y, second derivative, partial derivative with respect to x, second partial derivative with respect to y. I can also determine df over dx and differentiate it with respect to y. So I differentiate the function, find the partial derivative with respect to x, and then that gets differentiated with respect to y. We're going to look at this example and determine all of those. Okay? So also notation. This can also be shortly called fx. This fy. This fxx. This fyy. And this fxy. X first, y second. We're going to use this notation for this problem or any problem you want to pick. So let me tell you where they are, starting from page 539. Let's work on this example because I wrote it up there. I just made it up. Or you can make one up for me. Whichever you prefer, whichever you want to start with. So in this section, we're just going to learn how to differentiate functions of multiple or several variables. And in the next section, we will have to look at max-min for these functions. And that's the end of the course. So give me any function, or we go back to the function that I just invented, or you choose a function that you would like from page 539 on. You want to start with a simpler example maybe than the one I just made up? Okay, let's start with problem 5. I will come back to that problem. So f of xy, and that's 2x minus 5xy. And they're asking us to find fx, fy, and evaluate them. Okay, so fx means the partial derivative of function f with respect to x. So I differentiate with respect to x, and assuming that y is a constant. So when I differentiate the first piece, that's easy, it's 2. When I differentiate the second piece, -5 and y are constant. So I differentiate -5yx, which I get -5y. And then we're asked to evaluate, and they're giving us -2, 4. So fx at -2, 4. X is -2, and I have no x. And y is 4. So this is 2 minus 5 times 4. 20 with minus in front and plus 2. -18. Now let's also find fy, which is the function differentiated with respect to y, in which x is fixed. If x is fixed, means x is a constant, then this prime will be 0. So when I differentiate this, I differentiate y, and I have the constant left as -5x. When I differentiate with respect to y, all the others stay the same as fixed. Constant, in other words. So now fy at -2, 4, I don't have y, but I have x. -5 times -2 will be positive 10. Any questions? Oh, see, I multiplied by, so it's 20, right? 4 times this is -20. Careful. 4. Oh, hold on. No. So that's correct. It's correct.
You plug in for x, right?
Yes, of course. Positive 10. Good. Would you like to choose anything else? Okay, let's go back to this one, which is way more involving, right? So I'm going to copy it. Or if you want to make one up. Does anyone want to make one up?
This one's good.
Okay, very good. So I'm going to copy it. So it's x squared y plus 3y squared plus 4x cubed y squared. Okay, this is a little bit of a mess. So let's determine fx. When I determine fx, I differentiate the function with respect to x, and y is a constant. Constant. So when I differentiate this with respect to x, I get 2x and y. But when I differentiate this, there is no x. The whole thing is a constant, so this will be 0. Plus, when I differentiate all this with respect to x, y is a constant. I bring 3 in front, so I get 12, x squared, y squared. What if now we continue with fxx? So this is the second order. Second order partial derivative. It means that I have to have the first order, and fxx will be the derivative of this with respect to x when y is a constant. So when I differentiate this with respect to x and y is a constant, I just get 2y. Plus, when I differentiate this with respect to x, y is a constant, I bring 2 in front, 24, xy squared. This is the second order derivative with respect to x. You will see when we discuss max-min, we will have to differentiate this as fxy, meaning we have the derivative with respect to x, but now we need to differentiate with respect to y. So the fxy will be the derivative with respect to x, but now differentiated with respect to y, which means this is constant. So when I differentiate this with respect to y, I get 2x. When I differentiate this with respect to y, I have 24 x squared y. Now, let's go back and differentiate with respect to y. So what I would like to do now is find fy, fyy, and also fyx, and I want you to see what's happening here. So, back to the function. Now we want to differentiate. I'm going to copy it here so I can put the page away. So fxy equals x squared y plus 3y squared plus 4x cubed y squared. So I copied the function. So now I would like to determine fy.